All right, good evening. So we're going to talk about section 1.8 here and all the delightfulness that ensues here. So what I'm going to do here is I'm going to show you my screen, and then we'll just kind of get to work plugging away at some of these so you guys have an idea of where to start, what to start, how you should be thinking about this stuff. All right. So I'm okay at anticipating a little bit of the questions, but if I'm missing something or you haven't, you're not catching on to something, please let me know, and I will address those. Okay, so this lecture is just me, but in the future, hopefully there'll be more of you. And even if there aren't, please ask me some questions so that I know what to go on about. So here we go. So let's look at this. Just have a look at 1.8 and see where we go. All right. So screen share. Okay, I will say to you that trying some of the problems in here has been delightful. So some of these problems are really kind of a pain. So even when you look at this first one, I'm like, wow, this is going to be fun. So here's what's going on here. We have we have x minus 4 divided by x squared minus 49, and then we have x minus 7 and 4 minus x. That's wonderful. Okay, so let me just give it a start here and write this down, and you'll be able to see this is what the lectures look like. Okay, there's a little tab over here where I can make everything small. I leave my face up here, but I have a way of like just making mine, so that's how we'll do it. So we have S. Okay, actually I like my S's this way, but we'll do S is equal to x minus 4 divided by x squared minus 49, and then we have T, right, and that is x minus 7 over 4 minus x. All right, and what they're asking us to do is to multiply these two things together. All right, so that's not too horrible, right? Why it is, so we're going to say this isn't bad at all. X squared minus 49 times, and we're multiplying, so we can just do that. That's going to be x minus 7 up here. 4 minus x looks suspiciously like x minus 4. So before I go off and do this, could I rewrite this to say this is negative x minus 7 divided by x minus 4. All I did was pull a negative 1 out of this and put it somewhere else. So this negative comes out and I turn it into a positive. And then I got to switch the sign on the 4. So we're going to be divided by x minus 4. And of course I put a negative 1 in here for that. All right, and these are all times. Everything here is times. Okay, now it looks like I can actually cancel this stuff, right? Now we can go through and say, hey, we can, this will cancel nicely. Actually, let's go ahead and rewrite this guy too. So before we cancel, let's just go ahead and write this. This is going to be negative, because you can put the negative out front. And we're going to have an x minus 4. We're going to have an x minus 7, x plus 7. All right, times, I already got my negative, I put it out front, divided by, or times rather, x minus 7 over x minus 4. Now that looks like a problem that you would want to do, right? That's a lot easier to cancel. We can see, right, those cancel, we can see these cancel. And the only thing I'm left with here is just 1. All right, that's just stays at 1 here. So we're going to get a negative 1 over an x plus 7. Right, and that's what they want us to write down here. So we're just going to have a negative 1 over, and then we have a x plus 7 here. All right, delightful. All right, now we get to the hard one. Now we say, what's the domain of this? All right, this is a little bit easy, a little bit tricky to figure out. So even though you're looking at this and thinking, oh, well, the domain is just x not equal to 7. No. When you're dealing with operations of functions and you've got this string of them carried along and you've got this easy thing to deal with here, like generally this is the graph and this is the function I would rather work with. But when it's asking you to domain, it's a really picky question because you can't forget all the little pieces that went into making this. All right. And when you see, we get into graphing some of this stuff a little bit later, I'll show you, where some of that stuff comes from. Okay. Or what the interpretation of this is in a graph later on. All right? But for now, we're just going to talk about what the domain is. And I don't know if you guys have ever seen Christmas Carol. It's the one with Scrooge in it, so I'm going to be fairly confident that you've all seen that. And the first ghost he meets, right, is his old partner. And his old partner is carrying around a bunch of old chests that was his riches that he made. And he's got to drag those through the afterlife. It's the same thing when you're dealing with the domain. You got to go through and deal with all of this stuff you drag through the problem, and you're dragging that around with the into the domain just like that. Okay. The other thing is that the way I explain it as well is this function is not memoryless, right? It remembers that there was a part of it over here in the domain. There's a part over here in the domain. Usually in the fall semester, a lot of times we get to this about Thanksgiving time, and the thing to remember is like everybody has this Thanksgiving. I mean, not now, but in the before time, everybody has this Thanksgiving. Everybody's got that uncle that has brought up some kind of political situation or political topic that brings a big fight, and then nobody is ever to speak of that subject ever again in any Thanksgiving from then forward. So Uncle John could be dead. He will still not bring up the one topic that he went off on. It's the same thing. So can x equal 4? No, because when we had it over here, if x was 4, we'd have a problem. Can x be negative 7? No. When x was negative 7 here, actually x is negative 7 is at the end, so we know that's not true either. And then can x be positive 7? No, because if x was positive 7, this would have been a 0, and we can't have that either. Okay, so we accounted for what was the domain here, what was the domain here, and then in the end result, what was the domain here. We've accounted for everything. And they want you to put this into interval notation. So if we were in a face-to-face class, I would not have a problem with you saying that the domain, let's go ahead and write it in English. How do we want to say this? We would say the domain, right, would be all the real numbers except for, in set notation, this backward slash means except for, and then you could just write a list, right, with a little curly bracket saying except for these numbers. Interval notation, no, that's a lot harder to write. So what we have to write is negative infinity up to negative 7, union with negative 7 up to 4, union with 7 off to positive infinity. That one wasn't so bad, all right? So all this does is say, well, it's all the numbers up to 7, skip over negative 7, go from 7 to 4, skip over 4, and then go, oh, no, I didn't, I missed one, hold on. This is not right. Glad I have a moment to think about that. 4 to 7, union, 7 off to infinity. That's better. So we're going to go from negative 7 to 4, skip over 4, go from 4 to 7, skip over 7, and then go from 7 to infinity. That's going to be your answer as far as interval notation. All right, it is a giant pain to do this, but that is the system that we have, and that's what we're dealing with. Okay, but like I said, a little bit later classes, you'll probably be able to write something like that instead. When I say later, I mean like after Calc 3, later. But that's more advanced notation. Which again, I show this to my face-to-face classes. If you guys were taking a pen and paper test, it would be great if you could answer it that way. But they want interval notation, so this is what we're doing. Okay. Excuse me, that's my heater. You'll hear that a lot. Okay. Well, until it gets to be actual spring. But since we're going to get a polar vortex soon, you'll probably hear that a lot. All right. So let's look at another one. All right. Let's look at another one. Oh, well, I don't want to, here's the problem. You got to type all this stuff in, right? Union, more of that. So we're going from what? Negative infinity up to -7. Okay, we're going from -7 up to 4, not 74, up to, come on, there you go, 4 up to, right, 4 up to 7, another one, and then finally 4, or 7 rather, 7 up to positive infinity. Okay, so the brackets this side, this means include that endpoint. All right, we don't want to do that. This one says don't include the bottom one, but include the top one. This one is include the bottom one, but not the top one. This would be for individual numbers. Okay, infinities always get parentheses. Okay, so if you put a bracket there, that means that that's your endpoint. Infinity is not really a number, it's more of a concept. So if you put a bracket there, you're claiming it's a number, and you've been there. So quite honestly, if you put a bracket here and you put the infinity, please take a picture of it, because I'd really like to see where that's supposed to be. All right, but that's how you write that out all the way. I apologize that, you know, that is how our homework is, and that's how our book is. And boy, some of the problems in here are, boy, they're too much fun. Okay, they are too much fun. So doing some of these myself, I'm like, wow, I can't wait for them to learn like actual ones. Okay, you know, the better notation, the easier notation. All right, so this one is this one's going to be even better because it's plus, and pluses with fractions are horrid. So what do we have here? We have x minus 2 divided by x squared minus 9. We have a plus, right, because we're doing a plus. We have an x minus 3 over a2 minus x. Okay, so even still with this one, what I'm going to do is I'm going to change things around a little bit. Right, we have x minus 2. I'm not going to mess with this just yet, x minus 9. So I tried this one out, but we could do a plus and negative x minus 3 if we want, because I'd really rather, right, I'd have, oh, that's going to be a minus. I'd really rather have my denominator a little bit easier to deal with than what they had given me. Okay, it makes it a little bit easier to see what's happening. Okay, now what we got to do is we got to get common denominators here because they told us to add. Okay, so this was x plus 2, right? You could put the minus here, by the way. That's fine, but you're gonna have to remember it when you add again. So we have to add, which means we have to get common denominators. When you get common denominators, do not multiply out the denominators if you can at all help it. Okay. So we have x squared minus 9's here, okay? And in here, right, we need x minus 2's. Okay, I don't know why I wrote down plus. Okay, there's x minus 2 there. So what's going to happen here is that this denominator is going to match this one. This denominator is going to match that one, right? And I'm glad I checked this one out because, quite honestly, I was not interested in doing all of this. So this is going to be a minus. Right, this factors, right? This is x minus 3, x plus 3. How many x minus 3's we got here? 1, 2. Right? And then x plus 3. And then this is divided by x minus 2, x squared minus 9. So if you're thinking, I could cancel some stuff, like, no, this x minus 2 has got to be in both terms in order for you to cancel this. This x squared minus 9 has got to be something in both terms up here in order for you to cancel it. And it isn't. You're stuck with that. All right? It is a delightful looking problem, isn't it? Fortunately, this does spell out, because the first thing they're going to ask you to do with all adding fractions, the first thing they're going to ask you to do is to say what the domain is. Okay? In one way or another, they're going to ask you for this. All right. So you know that x can't be 2. You know x can't be -3. And you know x can't be +3. If you went through and multiplied all of this out, and I asked you for this, you'd have to go back to your first form in order to get that answer. So that's why we do not multiply denominators out, is because the next question in some way is, what's the domain? Okay, either to figure out where an asymptote is or whatever. But that's our next step here. All right, so in interval notation, because normally, again, I would love to just have you write this and be done with it, but we're stuck with connect, and connect's picky. So what we have here is -infinity up to -3, union -3 up to 2, union 2 up to 3, union 3 up to infinity. Okay, it helps if you write them in order. Okay, it really does. It helps you kind of sort out going from here to here if you write them in order. All right, so I am well aware that you've been on this planet for at least a couple of years, and you know that -3 is a smaller number than 2. But your book really wants to tell you, your book really wants to have you address this thing to prove to me that you know 2 is a smaller number than 3. Okay, which is why they do this. Okay, so sometimes easier said than done, right? But in any case, that's what they have here. It's just to prove to you that they'll let you do it. All right. What do we have here as an answer? We have x minus 2 squared, right? So we have x minus 2, and I'm going to use the caret squared, minus, and we have x plus 3. Oops, go away for that. X plus 3, x minus 3 squared. And then on the bottom, what do we have? We have x minus 2, parentheses, x squared minus 9. All right, so that should be close to what we have over here. Looks like we're good. All right. They said, yep, that's as ugly as it is, and it looks fine. All right. Now we got to go in their domains and write down this delightful thing. So we have what? Negative that to -3. Union. Okay. -3 to 2. Okay. Union. 2 to 3. Union. I told you this is too much fun, ain't it? So this is 3 off to positive infinity. All right. So I will promise you your exams will be just as fun as this, because we picked them out of the online homework and do that for you so that you've seen it before. And we can go in for all of that. All right. So those are tedious. Okay, that's what those are. They're tedious. Let's see what else we have. We have difference quotient. Okay, that's the next thing to worry about. So let me find the first one. Okay, you're seeing, right? Find a difference quotient and figure this out. Okay. Normally, I don't expect you guys to memorize the difference quotient. We are pulling them out of our books here to show you, to ask you the question. So that because you are not saying the formula here, I would not, this is not something I would, in a face-to-face class, I would give you the formula. Okay, and I'll see if I can't figure out how to do that on your exam. But I don't know right now. When I did it last semester with the Blackboard stuff, it didn't show up well. It didn't work. So I'll see if I can do that with these. Okay, and I'll work on that. But when you're working this, just be aware there might be a chance that you're going to have to memorize that formula. Okay, so I'll do what I can to not have that done, And if I can get it done, I'll let you know that you're not going to be responsible for it. But I may not be able to do that for you. So let's just talk about, in theory, what the heck is going on when they say difference quotient, and we'll draw you a picture of what's happening here. Okay. So what we want to know for the difference quotient. Okay, we want the average rate of change for a function. Okay, so we usually draw this random function here, right? And then we have an x, and then we have a different position, right? This here, the y value here, that's going to be f of x, right? And then x2 here. So we could say this is f of x2. And all the difference quotient is f of x2 minus f of x1 divided by x2 minus x1. Okay, that's really all we're doing. And you guys have a word, right? If I just changed f of x2, if I call it f of x2 y2, and I call it f of x1 y1, and then x2 minus x1, I am convinced, I know for a fact, you have seen this formula before sometime in your life, right? This is a slope. Okay, so what we're doing here is we are calculating the slope of the secant line. What secant means, it's inside, it's 2 points on a curve that's interior to it. Okay, that is different than a tangent line. I'll pick this one. Okay, so this right here in blue, that's going to be my secant line. And then we'll make a different color here. How about red? That's nice. And then if I put it here, and we have a line that just touches it at this one point, pretend this touches at one point, and that's the tangent line. Okay, and a lot of your calculus is going to be obsessed with calculating the slope of the tangent line. That is a lot of what calculus is. Okay, calculate the slope of the tangent line. But in pre-calc, we are calculating the slope of the secant line. Okay, you get 2 distinct points, and all we're doing is figuring out the ratios of the y's and the x's. Okay, now if it was that easy, right, we wouldn't have much of a class. So let's make this insane. Okay, and not really. Okay, this is just where the things come from and what's going on. Can I call x2? Can I say x2 is really equal to x1 plus some amount of x's, right? I mean, it's the same. If x1 were equal to 2 and x2 were equal to 5, then would you begrudge me for saying 5 is really 2 plus 3? Like, I don't think so. I think you'd be okay with me substituting x2 to say this is really x1 plus x plus delta x. And at that point, we kind of throw away the numbers and we just say that x2, which we just say is x plus delta x. Okay, so we don't really deal with the numbers because we're trying to say, oh, but this is for any x. All right, so we have a begin point of x. We have an end point of x plus delta x. Okay. In the previous one we did, this is just x1, x2. Okay, we're not changing anything. I'm talking about the same 2 points, all right? Except now they're dressed up more, okay? So we're talking about exactly the same 2 points, and instead of saying this is x1, we're just going to call it x. Instead of calling it x2, we're going to say this is x plus delta x. Do you remember what the y part is here? That's just f of x, wasn't it? And do you remember what the y part here was? Well, that was x2, right? That was f of x2. But we don't have x2 anymore. We have f of x plus delta x. All right? So instead of looking at this as f of x2 minus f of x1 divided by x2 minus x1, what we're going to do is we're going to call this f of x plus delta x minus f of x, all divided by x2. What was x2? It was x plus delta x minus, and x1 is just x. So far, do you see anything we can simplify? Just to point that out. So what we have here is f of x plus delta x minus f of x, all divided by delta x. All right. Now, if you were taking pre-calculus in like the 1970s, this is the formula they would leave you with. All right. That's what you would be told, and that's what you'd memorize. I am not this old, but I have books going back to that level. Somewhere around the 1970s, 1980s, they decided that delta x was too hard for students to understand, so we're going to call it h instead. Okay, that's all that h is. So when you see in your book that this is f of x plus h minus f of x divided by h, right? That's where this came from, and it's just the same way we've gone from here to something that looks insane, right? But it's really the same thing. All right, we're not talking about anything that's like majorly difficult. We're still figuring out a slope, just the slope of the secant line. And you're going to do something with this h when you get to calculus. You're going to do something in here. We're going to give it different values, and we're going to be able to do that. So what's happening? All right, like say you got a parabola, right? And I've got my x and my delta x. Right? We could do that. But do you see that if I picked a different x and a different delta x, we would get a different slope? We get a different secant line if we change the x and the h. Okay? So where the secant line is, or the slope of the secant line, kind of depends on both x's and h's. So if I don't have an x and an h in my answer, I'm going to think something is weird. Now, let's go ahead and do an actual problem so you can kind of get an idea of what we're supposed to be doing with this. The big hint is when you cancel this h, okay, that's what we want to do is cancel that h. We're going to be done. All right, that's how you know you finished, is you canceled this h here. Okay, excuse me. Let's go ahead and have a look at what's going on here. Let's start with an easier one. This is a good one. Find a difference quotient and simplify x cubed minus 3. All right. When I say easier one, it is easier, but this is going to be a long problem. All right. Oops. I want this. All right. So we have our f of x is equal to x cubed, what was it, minus 3? So let's see what happens here. We have f of, right? And remember, everywhere you see this x plus h, right? That's how function notation works, right? Let's get rid of the f. All right, but this is how function notation works. We have x plus h cubed minus 3, right? This is f of x plus h, isn't it? Right? We replace the x with whatever's in the parentheses here. Since we got x plus h in the parentheses, we got x plus h cubed. Minus 3. There's no x's, there's no h's, it's just minus 3. Minus, well, what the heck is f of x? X cubed minus 3. Okay? And this was just f of x. And then we're going to divide it by h. All right? So put bigger parentheses around here so we have a top and a bottom here. So now that we've strung that out a little bit, all right, here's what we have. We have x plus h cubed minus 3 minus x cubed minus 3 all over h. Now, a lot of students want to go through and start canceling this stuff. No, you got to go through and do this, okay? You cannot distribute the h, just pull the h out. Does not work that way, all right? Very common mistake is students often get the answer of 1. Okay, that means your slope of your secant line is 1, always, it's constant. You tell me, what function do you know that whose slope is always 1? It's that one. I am never going to give you this problem because it is way too easy. All right? Because all you have to do is like, hey, what's the slope? 1. If you get an answer of 1, this is what you did. So the hint is, if you get an answer of 1, you've done something horribly wrong. Go back to the beginning and retrack your steps, because I know what you did is you factored through the h, and it doesn't work that way. Okay, should never get an answer of 1. I mean, it's possible. It's just I am never going to give you that problem to do. So if your answer ends up being 1, you screwed up. All right, let's go through and do this. We have x plus h, x plus h, x plus h, and we have to do this. All right. So let's go ahead and start with this, right? Like we can group them apart. So this first part, right, we have x squared plus 2xh plus h squared times x plus h. You guys okay with doing, right? You've done this like since intermediate algebra, right? This is okay to go through and do that. And then the tricky part, right? We got to go through and do this. So this is x cubed, right? X cubed times x. We have plus 2x squared. There's 2 x's here that we're multiplying together. And then we have an xh squared, right? Xh squared. And then we have to do the other side, right? This is h times all of that. So we have a plus, right? H times x squared is going to be x squared h. We have a plus 2x, right? H squared. And then h squared times h is going to be h cubed. So we have x cubed plus 1, 2 is 3x squared h. 2 and 1 is plus 3xh squared plus h cubed. Okay, if you remember that formula from college, from intermediate algebra, good on you. That's fantastic. I never did, but that's where we are. Okay, so let me just write that in. This is my x plus h cubed is equal to this whole thing here. All right, so here we have it. We have x cubed plus 3x squared h plus 3xh squared plus h cubed minus 3, right? Minus 3 minus x cubed plus 3, right? I distribute this negative sign to both of these pieces. Okay, so we have a negative x cubed, positive 3. And then this is all divided by h. Okay, I feel for you. I know these problems, okay? And they get better. When I say that, I mean they get a lot worse. So I just want you to know that your education is more important than saving the paper. All right. A lot of times people will think, I want to save paper and spreadsheet. No, don't do that. Okay. First off, one of the statistics classes I dealt with, we did a lot of agricultural problems, and people plant trees specifically to cut them down and turn them into paper. Okay. You are not saving the rainforest by snipping your paper. Right. We're not cutting down rainforests to make paper out of. Okay, we're cutting down rainforest in order to have more room for cattle, but not for paper. Okay, so your education, if you have to use extra pieces of paper to get your math homework done, or to get your chemistry homework done, or whatever, you use them. All right, because with your education, you may be the person who figures out something really clever, right? And you wouldn't have had that otherwise. So you might cure cancer because you went through and did your math homework. And for human beings, curing cancer is better than what you could have done with that paper. All right. So you can always recycle the paper too. All right. So notice there's an h common in each of these, right? So we can pull out an h. And what are we going to have? We're going to have a 3x squared. This one's gone. Plus 3x. I still have an h left, right? I pulled one out, but I've got one left. Here, I'm going to pull an h out, and I'm still going to have 2. That's okay. Remember, we talked about the fact that in order to get the slope of the secant line, we're going to need an x and how far we're stepping. And that's fine. These guys cancel. Hey, we canceled that bottom h. You're done. Okay, your answer looks like that. All right, it's 3x squared plus 3xh plus h squared. All right, I know this does not look like an answer, but it is in fact the answer. Okay, which is why I tell you the hint. Like when you get rid of this bottom h, that's how you know you're done. Okay, and what you're going to get as an answer is not going to look like any answer you've seen before. Okay, but that is what you do. So just to kind of go back and take a look at what's going on here. Okay, what is this? X cubed minus 3. You guys remember college algebra, how to graph this? Right, it looks like a cubic, but it's got a vertical shift of 3 down. So it looks something like that, right? So when we're dealing with our 2 points here, right, we give it a point, and then we're going to go up with an h, and that's your slope of your secant line. Okay, you have a point and a point. Secant line is going to be very steep. It's going to depend on your x. It's going to depend on your h. If you take 2 points that are really close together, but you can't. That's what you're doing in calculus. It's going to almost look like a tangent line. It's still a secant line because you have 2 distinct points here. Okay, but that's what we're doing. You need the location and how far away are you stepping. And you can pick a point and then make your h over here, right? This could be your x, and this could be your x plus h, even though your x is a minus. That's okay. H could be negative, and get this one. All right. And that's what we're going to ask you to do next, is like pick a point for h, pick a point for x, and then tell me what the slope of the secant lines are. All right. So that's what we're doing. All right. There are several families of functions that we do this problem on. One of them is cubic. You're going to have to know how to do an x cubed plus something, right? We also use quadratics. Okay, quadratics are extremely important because quadratics are right. That's how gravity works, is quadratics. So and that's inverse square is how things fall off. So intensities from light, intensities from radio, falls off on a 1 over x squared kind of a thing. Gravity also 1 over x squared. So those are really important functions. You also have to do this to a rational function. When I say that, I don't mean we're going nuts and it's going to be something like this. All right. When I say rational function, I mean something in your homework. All right. Like 1 over x minus 5. All right. That's the kind of function I'm talking about. So 1 over x plus 3, x minus 5, x minus 1, something like that. All right. So we're going to find the difference quotient, simplify. That's what we're going to do here. Okay. So this one, rational functions have a little bit more of there's a little bit more involved here. It's not too bad. But we're going to say f or f of x is 1 over, what is this, x plus 5? Okay. Minus 5. X minus 5. I don't know if you can hear the dogs. I hope not, but we got a lot to say tonight. Okay. What does this look like? Oops. I want a positive 5 there. I don't want negative 5. Right. This was, remembering this from college algebra, right? This was a 1, 2, 3, 4, 5. This was a 1 over x that has a shift, right? Has a shift of 5. All right. We don't always have to make you work this thing out, but I think if you're going to draw this thing, it's nice to know, right? Build on our college algebra skills and remember those, and say, oh, that's right. This was 1 over x with a shift of 5 to the right. All right. That's what we're going to do. And again, we want to know, like, what's the difference quotient? So difference quotient, f of x plus h minus f of x, all divided by h. One way to memorize this formula is to write this down every time you do one of these problems. Okay, once you write down a formula often enough, you will know it. It's good practice to get in anyway to write down the formula before you plug stuff in, because later on, you are going to be dealing with very complicated formulas, and the mistake you really don't want to make is to plug the wrong things in at the wrong places. So write the thing down first, then you start going through. All right, this is 1 over, and then we have x plus h minus 5, right? Minus 1 over x minus 5, all divided by h. I hated these when I was a student, when I had to use paper, because they used a lot. There's like 4 lines going on here. This is nuts. All right. So how do we deal with two fractions? How do we deal with two fractions in the first example? We got a common denominator. So what we're going to have to do here is x plus h minus 5, x plus h minus 5. And then what do we do over here? X minus 5, x minus 5. All right. So let's go through the joy of figuring out two fractions here. So the top here, x minus 5. The bottom, x minus 5, x plus h minus 5. What did I tell you about multiplying these out? Not to do it. So on the top here, we've got minus x plus h minus 5, which means all of these things are going to get a minus in front of them when I distribute. Right? X minus 5, x plus h minus 5, all over h over 1. Okay. Why did I write the over 1 here? Is because we're going to end up with a complex fraction. And the next thing I'm going to ask you is, how do you deal with a complex fraction? Okay. So let's go ahead and deal with our fractions here. Okay, we'll do it one step at a time. We've got x minus 5 minus x minus h plus 5 all over, and this is the whole point of adding a fraction. All right, there we go. All over h over 1. Now, before we get to this part, do you see anything up here that might cancel? All right, a couple of things, right? So we have a couple of x's, those are gone. We have a couple of 5s, those are gone. So what do we have left here? All right, so here's what we have left. We have a negative h over x minus 5, x plus h minus 5, all over h over 1. We got a fraction on top of a fraction. You remember how that goes? That's 1 over h, 1 over h. Okay, so this cancels. Remember, this was the h we wanted to cancel, right? This one doesn't count. But this was the h we wanted to cancel. And there it goes. So we are left with negative 1 over x minus 5, x plus h minus 5. And this is, when they say simplify, this is exactly what they need. We did not multiply that at all. Okay, so what I don't want you to do, all right, this is a very common mistake students will do, so do not do this. Is they'll do f of x plus h minus f of x, all divided by h. And they'll say, okay, that's 1 over x minus 5 plus h minus 1 over x minus 5, all divided by h. Both those cancel, and we have h over h, and we end up with 1. And if you write that on your exam, and that's how the answer you get, that is not going to be well for you, okay? That is not going to end well. That's not quite the worst mistake you can make in life, but it's pretty close to it. Okay, you end up doing this in calculus, because they're going to ask you again in calculus. You know, there's some teachers like, I'm not grading the rest of your test. You don't know what you're talking about, okay? I had a chemistry teacher that would take off more points than a problem was worth. If he thought you did a stupid mistake, and you guys know what logarithms are because you finished college algebra. We'll talk about it again. So if you're like, I remember that word, but I can't spell it. I heard it before. Yeah, we'll take our time going through that, but we're going to see it again. But this guy would do those in his head, and if he thought like, wow, that wasn't very smart. Like you're, plus 10 out of 10. He's like, nah, minus 11. You were better off not coming in to take that test today. You were better off just taking a 0. It would have been better for you. At the end of the class, the end of the semester, we had to have about like a 30-point curve because somebody had gotten so many negatives that's what their score was. It was not me. But that's the kind of thing he would do to us. And every time I see this mistake, I'm always tempted. Like, man, I know they said it's only worth like 6 points, but that's really -7. Like the people around you should lose points because that was so terrible. So don't do that. Okay, try. I say this because somebody is going to do it, and I'm not going to call you out. I don't do that. I don't, don't advertise what you've done or what you haven't done. I'll when I post test scores, I might post numbers. I'm never putting somebody's name on it. Okay, you don't get to know what everybody else got. But I want to urge you, make a big deal out of it. Don't make this mistake. All right, just don't. It's a bad mistake to make. Don't do it. Let's look at a couple others. Okay, we've seen the quadratic, right? We've seen the quadratic. All right, or we've seen a cubic, and we've seen this one. Let's go back one more. Let's look at the difference quotient for this one. Okay, this is going to be a pain because this has a lot of x's in it. So we have a lot to do. All right. I have a feeling that I'm going to get to difference quotients, and I'll do them all. And I think that's going to be what we're doing today. Okay. So our f of x was equal to -2x squared minus 2x plus 4. And I'm sure there's probably a way to be cute with this and to make it a little bit easier. I'm just going to pretend like maybe we haven't had our coffee yet. And I'm just going to go through as if you didn't see something to be cute, because I don't see a lot that's really going to help. So, difference quotient. Okay, remember when we've gotten rid of this h, you're done. Okay. So that being said, take a look at what we got as our answer, right? So that doesn't look like an answer. Like, yeah, it does. We canceled that h. You're done. This one's going to be just, well, not quite as nasty, but it is going to be a long problem. All right, we've got -2. What do we do when we see the x? We replace it with x plus h. -2. What do we do when we see the x? X plus h plus 4. Minus, right? And then we have -2x squared minus 2x plus 4. Because it said, what's the function? We're just going to write down the function. All divided by h. All right. Can I do this x plus h squared business in one step? Do we need a mini step to do that? If you need to take a mini step to do it, that's fine. Wait, why did you distribute? Because I got to distribute here too, and I'd rather distribute everything on one line. Limited brain power here. I can think of one thing at a time, one step at a time. So my first step was multiply that out. My second step is, notice there's a lot of distributing that has to get done here. All right. So what we're going to do here, -2x squared minus 4xh minus 2h squared minus 2x minus 2h plus 4 minus 2x squared plus 4, or plus 2x rather, plus 2x minus 4, all divided by h. All right. Now, do you see anything that cancels? Well, what happened? Oh, this should have been a minus, so that's a plus. Okay, there we go. Make sure you got your things. Because this first term, that should always cancel. Okay, and then we've got a -2x and a +2x. We've got a +4 and a -4. So that cuts down, right? That cuts down the number of terms we have to do here pretty well. But, it's still not the funnest problem because we took a while to get here. So we have -4xh minus 2h squared minus 2h. Did I catch everybody? I think I did. All divided by h. Goal is to cancel this. So what's going to happen here is we have h negative 4x minus 2h minus 2, right? We pulled out an h, so we only have minus 2. We pulled out an h, this goes down by 1. We pulled out an h, that's by itself now. All divided by h. Those cancel. Negative 4x minus 2h minus 2. And there is your difference quotient. Okay, we cancel that h. Our job is done. So if that doesn't look like an answer, I know, it's terrible, but there it is. All right, you got one more family of functions, okay? And then I'm gonna let you go after that. Okay, we get square roots. Now, I know there is a problem in here for square roots, but I think it's really far enough. There we go. All right. X minus 3, square root x minus 3. Okay, and again, it might be square root of x plus 5, whatever, right? It'll be something like that. So we have f of x, right, is equal to square root x minus 3. You remember what that looks like? What's going on with that? Right? Again, minus means move to the right, and that. So we're looking for, right? We're looking for slopes of secant lines and on this function. Okay. All right. So f of x plus h minus f of x, all divided by h. So that is the square root x plus h minus 3 minus x minus 3 divided by h. Okay, one thing I want you to realize, this is not an equation. This is an expression. Okay, I mean, I know technically there's an equal sign here, but I'm going from the definition to the expression of the instance that we have. So these are not, you know, this is this, but they're not really equal. I mean, this doesn't really help you do anything. If I set them equal and start solving, we got x's, we got f of x's, that's not going to help. So you treat this as an expression. We do not have an equal sign. So something you can't do is like, how do we get rid of the square roots? A lot of people will answer, I'm going to square both sides. Like, you don't got one, you don't got both sides. You have one side. So you're just going to square it. Well, we can't do that, right? If we could start squaring things, then I could square my bank account. I shouldn't, because you know, if you have a decimal, right? If you have a decimal and you square it, you get a smaller number. So I probably shouldn't square my bank account. But if I took a square root, then that would work out better. Okay. But I can't go ahead and do that, right? I can't square. You don't want to square your tuition balance. It doesn't work that way. Okay. You don't want to square your debts, right? That turns them into positive numbers. Now they owe you money. Like that doesn't work. So squaring, no, can't do it. Okay. We have to have a better plan. Okay. We need a different plan. So we have x plus h minus 3 minus x minus 3 divided by h. Well, the plan is we're going to multiply by 1. We're going to multiply by something called conjugate. What that's going to do for us, it's going to get rid of these square roots. We're still going to have some square roots to deal with. But since there's a plus here, it's a lot harder to make this bottom thing equal to a 0 because we got a positive number plus a positive number, right? Because square roots, right? Look at the graph. Always positive, right? You're not going to have a positive number plus a positive number and get to a 0. So this is a little bit better because at least we can't divide by 0 anymore. So now the only goal is we have to lose that h. All right. Well, we multiply this through, all right? And again, you know, I know this is a tough step for a lot of students, okay, especially having done square roots in a while. So the square root of this thing times the square root of that thing is this thing because they are the same. Okay, so we have x plus h minus 3. When I multiply these together, let's go ahead and do that. So we have a minus x minus 3, x plus h minus 3. And then on this one, we have a plus, right? X plus h minus 3 times an x minus 3. And the last one, we have a minus, because minus times a plus is a minus. And we have x minus 3, right? And we have that. And on the bottom, there's stuff. Again, don't multiply this out. Just leave it. All right? Don't obscure where this h is. Just leave it alone. Okay. Do you see anything that can cancel? Okay. Do you see that we have a negative square root x minus 3, x plus h minus 3, and a positive x plus h minus 3, x minus 3? That this term and this term is going to be the same, and they're going to cancel. Okay, that's the magic of conjugate. Okay, is that middle term goes away. Okay, so when this is all said and done, x plus h minus 3 minus x minus 3, all divided by h. I'm just going to say stuff for a moment. Okay, we have x plus h minus 3 minus x plus 3. You see anything that cancels? You do. See some stuff that cancels, don't you? And we have x minus x. We have a minus 3 and a plus 3. Let's go back to blue here. Okay. So we have h over h times some stuff. These h's now cancel, don't they? We've done our job. We have canceled this bottom h. That was the whole goal, was to cancel that. All right. So what do we have? We have 1 over. You can't leave it as stuff. Okay, you can't do that. You can make a little notation so you don't have to carry it around all over the place, but you can't leave it that way. Oops, I have a minus 3. Okay. All right, plus. Okay. Does it make sense that in this function here, that my average rate of change, my slope of my secant line is always going to be a positive number? Right, it's always going to be a positive slope, no matter which 2 points I pick. It's not true for all the functions, right? If you take the parabola, you can have negative. It's okay. But we have positive number plus a positive number here. Even though it says minus 3, the worst we can get, right, is 0. Right? The lowest we can get is 0. Because if you try to take the square root of a negative number, well, then we got to go to complex numbers, and calculus doesn't really deal with that. Okay, you need a classical complex analysis to do that. But there we go. Okay, that's it. So we have 4 problems, right? We have quadratic. Right, that's the one with the x squared in it. That's what we did up here. All right. So you should definitely practice a quadratic. We started right with a cubic. Okay, that was the first one we did. These are tedious. Okay, there's a lot of parts to this one. Okay, we have rational. And rational, the big trick here, right, is the common denominators. Right, once we got the common denominators and added them together, it was just kind of like the problem solved itself as long as we chased that thing down, right? That's how that works. And then we have radical, all right? Again, multiply by conjugate. I'm going to say top and bottom, because sometimes people forget. And then chase it down, and then solve. Okay, so quadratic and cubic, sorry, you just got to work these guys out. They're awful. Okay, rational, the key to unlock this one is just to get common denominator, just add them. Okay, or just subtract them. That's all I want you to do is just add them. Radical, you got to be a little more clever, but you know, the way to be able to add them is to multiply by the conjugate to move where the square roots are. and then the problem falls apart. So those are the four. Technically, I guess I could ask you for a linear one, right? But this is, right, if I ask you like, hey, what's the slope of 2x minus 5? 2. We don't have to go through all of this. You just point it out to me, okay? So I don't like to ask you, I don't like to ask you these because these are too easy. Right? And then I will never ask you this one because then you're going to get the answer of 1. And anytime you get the answer of 1, I want you to feel as if I've done something horribly wrong. I feel a ghost. Okay, I feel something, and to look back over here and like maybe do it a different way. Okay, but I want a cold shiver to go down your back when you get this answer and say, "Oh, I got a 1." Like, oh, something's wrong. Okay, but if I asked you a linear one, hey, what's the slope? Right? Not too bad. So these are technically the 5 that you have to be able to do. I'm very unlikely to ask you a linear one because it's very easy. But go practice. Make sure you can do one of each of those. All right. Make sure you can do one of each. I won't ask you 4 problems. I'm only going to pick one, but I'm just gonna roll a die to figure out which one I'm going to give you. Okay, it's a random chance. So practice these. All right. I think that's probably a long enough lecture for the first one. We'll come back to 1.8. I'm sorry, it's a long section. Okay, it's got a lot of weird details in it. We'll do some function composition, right? Because that's the next topic here. But practice your difference quotient. It's not nearly they're not easy, but hopefully this gave you a little bit of a chance to get through it. All right. So I'm going to go ahead and stop us there and wish you a good evening and fill out your surveys if you're still listening. Okay. And finish that up. Okay. So we're going to be done.